Hi, I'm Tiffany in Group 16, and I'm now talking about the maximum likelihood discriminant rule, including linear discriminant analysis and quadratic discriminant analysis. Discriminant analysis is a traditional classification method of machine learning. LDA uses the full likelihood based on the probability of x and y, and it is a generative learning and linear method. Quadratic discriminant analysis is similar to LDA, but this is not the linear method. Firstly, we use GLM in R to set a logistic regression model with all selected variables. 30 variables are selected. The results show that only 10 out of the 30 variables are selected to the fault found in those p-values are smaller than 0.05. Therefore, other 20 variables can be eliminated out because of their slight relationships with fault found p. The 10 selected variables are used in the model. If too many variables are used in the model, it will cause an inaccurate result. Due to the further selection, only 2 variables with lowest p-value are chosen to fit in the QDA model, which are fault and base policy. It is suggested to use cost validation for our project. Sample in R is used to randomly choose 80% of the dataset, about 12336 records, for training process, and 20% of the dataset, about 3084 records, for testing data. Training data can be used to let the computer learn the dataset with a big number of records. Testing data is to predict whether the computer learned the model successfully or not. In order to make a fair situation, all three methods are both used 78075 for random seed. In 3084 testing data, we can find 169 fault cases by using quadratic analysis discriminant method, and other 2915 cases are cited as real cases. The accuracy rate is about 94.52%, which is very good. The error rate is about 5.4799%, which means some cases are failed to find, but it is still acceptable as its rate is quite closer to 6%. Although we calculate a relatively good result by a particular seed, it does not have enough power to prove that the model is the best choice for predicting the result. Therefore, more results are needed to generate out using different seeds. We randomly generate 35-digit numbers by round function in Excel and substitute them into the program. The FHLDA and QDA results are far more closer to 6% after repeating the program 13 times, which is from 5.98% to 5.99%. It is proof that discriminant analysis are relatively good classification methods when comparing their accuracy. Compared to other methods, it is a relatively trivial method for people who are beginners in machine learning. The methodology of discriminant analysis are based on the logistic regression. The corresponding token are easily found in built-in functions in R. For example, LDA, QDA, and GLM. No packages are needed to be downloaded. Moreover, as no packages are needed, the program running time is relatively faster than other methods. Also, discriminant analysis is good to use when starting a project. Assumingly, we have no ideas about the raw dataset in the very beginning. Only a thing that we can do is to eliminate some unrelated variables. Undergoing a logistic regression is exactly a help for our code. That's the end of my sharing. Thank you.